Okay, so I have been thinking about it for a while now, like genuinely sitting with it. And I wasn't sure if I wanted to make this video, honestly. Because the moment you say the biggest lie about software engineering, people automatically assume you are going to say college is useless and LeetCode is a scam, or AI is going to take everyone's job, right? So that's not this video is. The lie I am talking about is much quieter than that. It's not something anyone told you directly, it's something you picked up slowly from the culture around you. And the scary part is, I believed it for years, genuinely believed it. And I think most people sitting in engineering colleges right now, most people grinding problems at midnight, most people obsessing over their lead code count, they believe it too. So give me a few minutes because I want to unpack this carefully. Let me start from the beginning. So I graduated from an IT Rourkela. I have done BTech, and before that, years of what I'd call the grind. If you know, you know. The first year, you are figuring out how college even works. Second year, someone mentions DSA, and suddenly you are watching YouTube tutorials at 1 a.m. trying to understand what a linked list is, right? Third year, lead code enters into your life. It's a personality trait, and by fourth year, placement season hits and everything just compresses, right? I ended up solving more than 900 problems on lead code. That's not something I'm saying to flex, all right? I'm saying it because I want you to understand the depth of the belief I had. I genuinely thought if I become good enough at DSA, then everything else would follow. Get the coding right, get the job, figure out the rest later, right? And this is something nobody told me directly. Nobody sat me down and said, hey, just code and everything will be fine. But somehow that was the message everywhere, in how people talked about placements, in what seniors advised, in how we measured each other. Lead code rating, code forces rank, number of problems solved. That was the currency. Now, here's the thing, and I want to be really careful here. Coding is genuinely important. I'm not going to sit here and tell you that solving 900 problems was useless. It wasn't. It changed how I think. And when you spend that much time with problems, you start developing something that's hard to describe, like a relationship with complexity. You stop panicking when something looks hard. You start breaking things down automatically, right? You start noticing patterns in the way problems are constructed, and that's real, that stays with you. And the interview process, especially for the product companies, especially for the kind of roles that most CSS students in India are targeting, DSS is still the gatekeeper. You don't get to show the personality if you cannot solve the technical problem in front of the interviewer. So I'm not here to tell you to stop grinding lead code, but here's where it gets interesting. At some point during placement season, I think I was somewhere in late third year, early fourth year, I started noticing something that didn't fit my mental model. I knew people, smart people, people who could barely do a medium lead code problem, people who would just get stuck on basic recursion, and they were doing fine in interviews. Not just fine, some of them were clearing rounds at that I was struggling with. And I remember being genuinely confused, like I couldn't explain it. Meanwhile, I knew people, strong coders, people I had watched solve hard problems in competitive programming, right? People with impressive competitive programming ratings who were stumbling, and not on the DSA part, on something else. I didn't have a word for it at that time. I just thought, that's weird. And then I pushed it aside. Because there is this really comfortable thing that happens when your worldview doesn't fit the reality. You just call it an anomaly and move on, right? And that was the mistake. Let me tell you about a specific kind of moment. You are in an interview, you have seen the problem before, you know the approach, you start coding. And somewhere in middle of it, the interviewer asks you a question, not about the code, about your thinking, about why you are doing what you are doing. And suddenly you realize you don't fully know how to answer that. Not because you don't know the answer, but because you have never had to say the answer out loud before, right? You have spent hundreds of hours thinking inside your own head. You have solved the problem internally, but explaining the problem, explaining the process, making someone else follow your reasoning in real time, that's a completely different skill. And I think this is one of my biggest misconceptions from the period. I thought communication was just about speaking English, right? Being good and fluent at English, or having a certain kind of personality. That's not what interviewers care about. What they care about is clarity. Can you make me understand what you are thinking? Can you take something complex and make it followable? Can you catch yourself, right, going wrong and self correct yourself and being out loud, right? That's not about English, that's about thinking. And it's trainable, but only if you practice it like a skill, which most of us never did. We practiced coding in silence. We optimized the correct output, not for explainability. And this is one of the first real cracks I noticed in the just be good at coding belief system, right? The second crack was projects. Okay, so every engineering student has projects, right, on their resume. That's just table stakes at this point. But there's a version of project that most of us have, and then there is a version that actually matters. The version most of us have is found a tutorial, followed it, maybe changed the color theme and put it on the GitHub and called it yours. I'm not judging this, I did it too. But here's what happens when you go into an interview with that project. The interview asks you about it, a few layers deep. Why did you choose this approach? What would happen if the load increases, right? What was the hardest decision you made in while making this project? And if you only followed a tutorial, you hit a wall after the first two questions. You start saying things like, I just followed the standard approach or something like that. And the interviewer doesn't know what to do with that because the project was supposed to be the evidence of what you can build, right? And the questions are trying to determine whether you actually understand what you built. So this is where the depth matters so much more than quantity. I'd rather have one project where you made actual uh, decisions, where you hit the real problems, where you changed your mind about an approach, where something broke and you had to figure out why, than having five projects, right? Because understanding what you built, actually understanding it, that signals something much more valuable than the project itself. It signals engineering thinking. And this is where I want to introduce a distinction that I think gets completely lost in placement culture. There's a difference between coding and engineering, right? They sound like they are the same thing. They are not. Coding is writing correct syntax that produces expected output. And engineering is deciding what to build, figuring out why it might fail, making trade offs, communicating decisions, and taking responsibility for something that has to actually work. The best analogy I have heard, and I'm probably going to butcher it, is this: knowing how to write sentences doesn't make you a writer, right? It is a necessary skill, but it is not a sufficient skill. A writer has something to say, right? A writer makes choices about what to include and what to not. A writer is thinking about the reader, not just the page. And that's the difference. And for a long time, I was optimizing for the sentences. I was getting better and better at syntax and logic, at patterns and algorithms. And I thought that this was the whole game, but it wasn't. And looking back now, I think placement culture in India specifically, and I want to be nuanced here because this is it's a structural thing, not a personal failure. It accidentally creates this very narrow definition of what software engineer is. Because of how your hiring works at this stage, especially for campus placements, the filter is almost entirely DSA. And that makes sense for the practical standpoint because it's a scalable filter. It's somewhat it's somewhat objective. It gives companies a way to process hundreds of students quickly. But here's the problem. When that filter becomes the goal instead of the gateway, you end up with the engineers that who have optimized for the test and not for the job. And I genuinely think a lot of us, including me for a long time, were training to pass that test rather than training to be something. The difference between those two things is everything. Now, let me talk about something that I think is going to be increasingly important, and I don't think students are thinking about correctly: AI. Specifically, AI coding assistants, GitHub Copilot, Claude Code, Cursor, all of it. And I'll probably make a dedicated video on this because I honestly think most students are thinking about AI completely wrong. Here is what I see happening. Some students are terrified that AI is going to take all the jobs, and some students are very excited that I don't need to learn anything. AI will just code everything for me. And both of these are wrong, right? But here's the more interesting thing. Think about what happens when AI gets genuinely good at generating code, like really good, right? It means code itself becomes cheap to produce. The raw act of writing syntax, going from I need a function that does X to the working implementation, that gets faster and easier. So, what becomes more valuable? Everything else, right? Knowing what to build, knowing why one approach is better than another, right? Knowing when to throw away a working solution because it solves the wrong problem, communicating what you want clearly enough that the AI can actually help you, right? Evaluating the output critically instead of just accepting it. These are the judgment skills, and they are not taught in any DSA course. And here's the irony, this is actually the same thing I was describing earlier, just made more urgent by AI. The skills that were already undervalued in campus culture, communication, engineering thinking, depth of understanding, good judgment, those are exactly the skills that AI cannot replicate. The future isn't AI writes code and engineers become useless. The future is AI writes code and the engineers who understand what code is for become more valuable than ever. And I'll go deeper on this particular thing in a separate video, but I wanted to put this on the table because it connects directly with what I'm trying to say. Okay, so let me actually say the thing I have been building up to. The biggest lie about becoming a software engineer isn't that you need a degree. It isn't that lead code is the only path. It isn't even that AI won't affect the field. The lie is this: if I become really good at coding, everything else will automatically fall into place. That's it. That's the lie. And it sounds so reasonable when you first encounter it because coding is genuinely important and becoming good at it does unlock a lot of good things. So the assumption that getting better at coding just compounds in all the directions, it feels intuitive. But it's not true. Coding doesn't automatically teach you how to communicate a technical decision to someone who isn't technical. Coding doesn't automatically teach you how to break down a vague requirement into something buildable. Coding doesn't automatically teach you how to push back on a bad idea respectfully. Coding doesn't automatically teach you how to work with people who have completely different working styles. Coding doesn't automatically teach you when to stop over engineering and just to ship something, right? These skills don't come from writing the code, writing more code. They come from building things, working with people, from making decisions with incomplete information, from being curious, right, about the problem beyond the implementation. And here's the part that I genuinely struggled with accepting. A lot of the most impressive software engineers I have come across, people who have built things that actually worked, people who had a real impact, they weren't the people who wrote the most elegant code or the fastest algorithm. They were the people who understood the problem most deeply. They could explain what they were building and why it mattered, right? They could think three steps ahead, right? They asked questions that others didn't even think to ask, right? The code was a tool, not the identity for them. So let me tell you what I would do differently if I were starting again in 2026. And I want to be careful here because I don't want this to turn into some forget DSA, focus on soft skills. That's an overcorrection and it's just wrong, right? DSA matters, coding interviews are real. You need to be able to solve problems. That's not changing overnight. And for the kind of roles most people watching this are targeting, ignoring DSA is not an option. But here's what I'd change. I would treat building as the first class activity, not a side activity. Not tutorial following, building, like building yourself. Picking a problem that actually annoys me and trying to solve it. Making real decisions, running into walls, debugging things that make no sense, right? Shipping something, even if it's a small. Because every hour I spent building something real taught me more about software engineering than many hours of solving abstract problems. I would also take communication seriously as a skill, not as a personality trait. I think a lot of people treat communication as something fixed, like you are either good at it or you are not. That's wrong. The specific kind of communication that matters in engineering, explaining your thinking clearly, asking precise questions, writing clear commit messages, documenting what you have built, that's a learnable and practicable skill. And then I would take the AI tools seriously, not as a replacement for learning, but as the way to accelerate it. The students who figure out how to work with AI effectively, right, who use it to go deeper and not shallower, they are going to have a significant advantage. But most importantly, and this is the thing I wish someone had told me earlier, I would be a little less obsessed with metrics and a little more curious about the work itself. Less focused on lead code count, more focused on whether I actually understood what I was building. Less focused on resume bullets, more focused on what I could explain from the first principle. Less focused on passing the interview, more focused on becoming someone who genuinely understood software. Because here is the thing about interviews, you can optimize for them, right? You can get quite good at the specific game, but eventually, whether it's in the interview itself or in the first month of the job or in the code review where someone asks you why you made that particular choice, the depth shows, or the lack of the depth shows, and no amount of grinding can substitute for genuine understanding. I think this is something that placement culture doesn't really tell you, or maybe it cannot, because it's hard to measure. You cannot measure how many problems someone solved. You cannot easily measure how well they understand what they are building. But interviewers can feel it, right? They can feel it. Senior engineers can feel it. And it's the difference between someone who can execute a given task and someone who can be trusted to figure out what the task should be in the first place, right? I want to end on something honest. I failed interviews multiple times, and in the middle of that, the easy answer, the psychologically correct answer, right, or you can say psychologically comfortable answer, was always I need to solve more problems, right? Because that was something I could control, that was something with clear metrics, and that's why I ended up solving more than 900 problems. And there is nothing wrong with that, as a response to failure. But sometimes you genuinely do need to solve more problems. But sometimes the answer is something harder to quantify. Sometimes the answer is that you need to be able to articulate what you are thinking better. Sometimes the answer is that your understanding of the problem has to go deeper than the solution you are implementing. Those things are deeper, they are less measurable, they don't show up on a profile with a green check mark, but they are the things that actually matter once you are on the other side, right? All right, in the end, I would like to say I spent years trying to become better at writing code, and the funny thing is, the best engineers I have met weren't obsessed with code, they were obsessed with problems. Now go build something, I am watching you.